took advantage of. There's a social suicide. I refuse to die, not by your side. So I'll take what I can from you, then I'll hide. And send the lucid dreams for another time.
So now it's time to talk about functions. Functions are the backbone to your application. They're actually really cool because they help us execute things over and over and over again, right? So we've already kind of figured out how to use a loop to parse out data, but what a function can do is call that loop many, many times. Now this is going to make a lot more sense once we actually jump into it, but before we do, we're going to talk a little bit more about lists, and then we'll jump into actually defining our own functions. So let's go ahead and get started. What we're going to do now is define a mixed use list. That is a list with strings and integers. And then we're going to do that for loop again and parse that data into two different kinds of strings. And then we'll actually define a function. So first off, let's do some stuff with strings though. And I'm going to say items equals to, and I'm going to say mic, and then phone, and then some random number, or a random decimal number, so number with decimal places, basically. Some other things like a name, bag, whatever. It doesn't really matter what we're saying here. It's just mostly the fact that it is mixed between integers, decimal integers, as well as strings. So we do that, we see items here. Now, we have that for loop that we talked about before where we actually pulled out items based on what they were, what type that they were. So what we're going to do now is discover a few things with that prior to actually jumping in the for loop. So what we see here is actually a float number and an integer. So float numbers and decimals are close to being the same. They're just slightly different data types, but basically know that if it has a decimal and then numbers after it, that's considered a float number. So we can check that by doing is instance and then write out a float number, and we could say int for integer. It'll say false. If we go up and we do float, it'll say true. So our parsing of this list will actually make a difference here. So before I actually go through that for loop and parse it, let's actually do some things with a list that we might want to do. First of all, we might want to actually sort lists. We might want to have them being sorted in some sort of way. Now, there's actually a function built in called sort. But if I hit enter, it's going to say unorderable types, float, less than string. So we talked about the float number, and that's this. But even if it would only had integers and strings, it's still not going to sort in the way that we might want it, right? Because there's really no logical way to sort numbers and strings. So numbers and characters. I can't really alphabetize those things. So instead, I'm going to make a new list, and we'll say string items equals to, and I'll just say ABC, JM, ED, and just some random other characters, right? Okay, so, and then I'll do some lowercase ones as well to illustrate a few points here. So if I do string items, again, I see that they're there, and if I do dot sort this time, I can see string items is, string items, str items, is now sorted, but it's not sorted in the way that you might expect. In fact, it's sorted by alphabetical in respect to their actual casing, right? So AD capitalized is the first in this list because it's first off sorting everything that's capitalized, and then it's sorting everything after that. So to actually overcome this, we can do string items and then sort, and then we'll do key equals to str.lower. And now if we see str items, we now see them sorted alphabetically. And this will definitely work for English characters. It might not work for other characters, but it'll definitely work for English characters. So we see here is AAA, ABC, and so on. It's sorted correctly. So that's kind of nice to know. There's one more thing that we can actually add this if we wanted it in reverse. We just add the reverse parameter, and we say reverse equals to true. And that will actually reverse this list. Cool. So what you might be wondering is, hey, but it's actually sorting this particular list, but what if I wanted to sort a different sort of list? Meaning, what if I didn't want to sort my original list, but I wanted to have a new list that's based off my original list, but sorted? So let's go ahead and see that. I'll do sort items, and then I'll do new items equals to, and we'll just do sorted. This is a built-in Python function, and then we do str items. I press enter and do new items. And now it does that same sort of sort that we saw before without that key. So new items is actually that original sort right up here. So what we can do now is also add those same things, and that's key str.lower, and then reverse equals to true. And then we do new items again. Now we've got new items being sorted in reverse alphabetical order, and then our str items is still the original list. So that's kind of cool as far as sorting is concerned for strings. Now, what if we wanted to sort for numbers? Well, let's go ahead and make a new list called int items, and I'm going to just put in some integers in here, as well as decimal or float numbers, and then we'll come in and just add in some stuff. Okay, so now we got int items, and the same thing's true. If I do sort, I see int items. It will actually sort them by smallest to lowest. And if I did sort reverse equals to true, it's now largest. It's going to be largest to smallest. And then the sorted thing is still works on this as well. So new sort equals to int items, and that is sorted int items. Let's do that again. So new items equals to sorted int items. And we could say reverse equals to true. And new items will be the reverse of this. And it looks like we might have done it twice. So we'll say new items and int items. So in this case, we actually discovered something that's kind of cool. It's not intuitive, at least it's not the expected behavior, right? So when we did reverse equals to true, it's not actually reversing that list. It's reversing based off of whatever's in that list, right? So first of all, it's sorting those items, and then it's going to reverse that order. So when we did reverse equals to false, it actually sorts them smallest to lowest. So this reverse call has almost nothing to do with the actual list that it's sorting. It actually has to do with the items inside of that list. So it sorts the items first, and then it reverses them or not. And so that's how that sorted function works. Cool. So from here, we can actually do some stuff in addition to lists with numbers in particular. So int items are numbers. So we can actually calculate and bring all those numbers together by using the sum method. So sum int items, and it actually combines them, so it adds them together, right? So that's a function that's built in. And then we can also do the length of it, right? We've seen this before. So length of items gives us 5. So this also means that I can actually average these items out. So I'll say total equals to sum of int items, and then the average equals to the total divided by the length of int items. So the average, oops, I spelled average wrong. Average, the weird average, is this, right? So this is on Python 3. So let's actually look at Python 2 to see the slight difference, and we'll talk about how to actually fix it. So Python 2, we're going to take those same numbers, and we're going to grab int items here, and then we will do the total is the sum of those int items, and then we'll do average number equals to the total divided by the length of that, and then we do average number, and we get that same average number. Now, this is true for the fact that we have a float number in here. So let's try it with a whole nother one, and I'll say instead of int items, I'll actually do a sum or a total that is not a float number itself. So instead of actually going through a whole new list, I'll just give a new number, and we'll say average number 2 equals to, some number, and then the length of int items. And now we see average number 2, and it gives us a rounded number. Let's try that exact same thing in Python 3. average number 2, and we get the rounded number. So this is an example of when we want to use a float inside of this actual equation here. So we're going to do average number 2 is now equal to that number divided by parentheses. We'll do length of int items, and then we'll multiply that by 1.0, and then we'll do average number 2, and it gives us out this average number. So these are slight little things that are different about Python 2 and Python 3, but when you're designing your programs, you want to make sure that you're doing stuff like this just so it works on either one because of how you're wanting to support your programs. Now, if you were just only working with Python 3, this will work fine, but again, this is kind of that fail-safe for either version. And this is definitely something that you'll see in a lot of tutorials, but also a lot of packages or Python modules that will actually do this. Cool, so now we've actually seen more about lists, and we've seen some built-in functions that do some things for us. So before we actually start jumping into writing functions, there's something I want to mention, and that is what we've been writing so far, all the code we've been writing so far is in the Python shell. Now this is really good for testing, but long term, you're not going to put it in the Python shell. Instead, you're going to put it into an actual document, a .py document or .py document. This document will house your Python functions, and we're actually going to work with these a lot. This document is often referred to as a Python module that's like related to Python, which we'll also talk about more later. But what we really want to do is write our function inside of this .py. And the reason for this is, well, there's several reasons for it. Is one, we don't have to retype everything. We can just copy and paste. And two, it helps us be a little bit more organized with our code. What you saw on the list is we were going back and forth with all the different stuff. And now what we have is we can actually just copy and paste things, or I could exit out of Python and actually come right back in and just paste some code, and it will actually be there. So that's something that we definitely want to do. And the text editor, or the way we're going to make these .py documents or .py documents, is using something called Sublime Text. Now, Sublime Text is a text editor for all types of code. We can use it for Python, we can use it for Django, we can use it for JavaScript. There's a lot of use cases for Sublime Text, but the program itself is not unique. It is just a software to help edit our code. That's it. Like, Sublime Text is definitely not the only thing that's out there. There's a lot of things out there that you can use, and if you find something that you like better than Sublime Text, by all means, go ahead and use it. But it's specifically these text editors edit code, but this is all open source code, so you don't have to use any particular text editor. This makes a lot more sense when you think of things in terms of Microsoft Word, right? So Microsoft Word itself, for a very long time, you could only use Microsoft Word to edit a Word document. But a .txt file, on the other hand, could be edited in Word. It could be edited in WordPerfect, that if you remember that program, it could be edited in Apple Pages and so on. Now they kind of all edit with each other and they work a little bit nicer together, but there was a time where they didn't because they're all proprietary. Now, open source code can work with a lot of these text editors. Sublime Text is not free, and they are not an affiliate. I would love for them to be one. If you guys are listening, please let me know, because I would love to work with you guys. It's really just a software that I like and I use a lot. And the difference between the trial version and the paid version is literally a nag on the corner of the screen. So I'm going to go ahead and open up Sublime Text into a starting place for us, and I'll explain this in just a second. But again, that paid version, this is a paid version. It just doesn't say unregistered in here. But other than that, it's exactly the same. So that's another thing that I think is really cool about these guys, is that they basically give away their software for free and charge the people who are willing to pay for it. Cool. So let's go back into the functions. Now what we see here is the list of things that we just did, right? So we wrote all of this code out inside of the shell just a moment ago. Now, what we also should notice here is the colors are different, right? So this is something else that's really nice about text editors, is it has this like kind of code completion, syntax highlighting stuff. So basically, it's like when you work in Word or in Apple Pages, it actually, like, sometimes it'll do the actual it will actually do spelling check for you as you go through it. This is kind of very similar to that. It does spelling check in grammar and Word. This does syntax and color highlighting for us, or code highlighting for us. So this is the code that we just did. So if I go ahead and copy this, and at the end I'm going to print out str items and print out num items. And notice how easy it is to type that out. Once you get used to text editors or code editors, especially like Sublime Text, it's going to make your code typing a lot faster. And I come out here and I see that that for loop actually works. This is really cool, and it's very important for this next part. And now what we're going to do is actually make our first function. So we're going to define a function, and I'm going to call this Parse Lists. And it's going to take in some underscore list as an argument. And what we'll do here is we'll say the str list items equals to an empty list, and then the num list items equals to another empty list. And we're just going to go ahead and copy this for loop that we just did. And I want to tab everything in. Notice that I'm using spaces here, so those little dots are spaces. I do actually tab it, but they're treated as spaces, not as tabs. And then we are going to actually go ahead and copy these list items and change them accordingly. And then we're just going to say return, and I want to return these two lists themselves. Okay, so items right here should be some list. So now I just created this new function. We're going to go line by line and use it in just a second, but I'm going to explain everything after we actually go through it. Parse lists, and I'll say items. And I'm just going to go ahead and print out the parse lists of items. Okay, so let's go ahead and copy this. And I'm going to bring it into my terminal. And notice it does actually do everything that is expected. One key thing here is items is actually, it's actually defined up there called items, right? So that's how we are actually able to do this. So let's go line by line on this function. Now, the first things is we have these empty lists, and then we go through that for loop creating these lists, and then finally we bring these lists back. So calling this function, that is executing this function, running this function, is as simple as writing out the name of the function and using parentheses. In this case, we actually need some data to come through in here, so we have some input data. In this case, it's called some list, right? So I have to actually put in a list here. So this is just an argument, something arbitrary. I could say ABC here, and I could put this in as ABC. But wherever I use it inside of the function, I have to use it as what's coming through. We're going to do a lot more functions, so don't worry if this doesn't fully make sense. But basically, that's how this works. So we are coming through here, and we now have a way to parse our lists full of if the items are different. So let's go ahead and actually test it out some more. I'm going to come in here, and don't worry about writing this code. You can just watch it, and you can reference this code on GitHub. So I will show you the link to GitHub at the very end of this video. And but for now, what we see here is various things that we've already done. So I'm going to say items 2 and then items 3. And now I'm going to just change it up a little bit, and I'm going to get rid of everything in here, except for now I'm going to put another list in here and say 1, 2, 3, blah, 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 and some other string. And now we're going to parse items 2. Let's see what happens here. So I'm going to go ahead and copy this, and we're going to paste it in there. And all it gave us back was the list of strings that were in items 2 and an empty list for integers. Why is that? Well, this function itself, or this for loop, is looking for each item in there. So each item, it's looking for every single one, and it's going to check that individual item, whether it's a float or an integer. If it's one of those, it'll append it to that number list. If it's a string, it's going to append it to the string list. Otherwise, it's not going to do anything. So in the case of this one, this third item is a list item, right? So another way would be to look at it like this and put it in as a list item. So we go ahead and copy that, and now we see that, oh, this variable right here is a list item. It is not a float, it is not an integer, and it is not a string. So that's not going to be included in the results. Now, of course, the things inside of it are integers and strings, but that doesn't matter because it itself is a list, right? Hopefully that makes sense. I mean, even if it was empty or it had a list of more lists, it probably wouldn't work out that well. So that's where this function doesn't actually parse every string item or every number item, because it still is worried about these lists, and it's kind of not working that great in that sense. But as far as something like items 3, it will absolutely parse these strings and numbers there. Okay, so that might be a little bit more of a complicated function than we need to know at this time, but the point here was to show you how to use the for loop and how to use it with a function. Now let's go and do something a little bit more simple. If you remember, we did this thing called sum, and then we took in a list of numbers, and it actually added them up for us. So if I go ahead and copy that and paste it in here, it actually does that for us. Now we could do this using our own function. So I'll do define mySum, and again, it's going to take in a list as an argument, and instead of calling it list, I'll just say my num list. And then we're going to do something very similar to parse lists. We want to make sure that the items in here are either float or integers before we actually proceed with it. But I'll just say total equals to 0, and then I'll say if, first off, we want to loop through that past list. So for I in my num list, I'm going to say if instance is float or integer. Then we will say, or if that iteration, that particular item, if it's a float or integer, then we'll say total plus equals to I, and that's it. And then finally at the end, we'll just return total. So this is a little bit better of a sum function than this, and I'll show you why. So first off, we'll do sum, and then now what we're going to do is sum items 3. Right? You're going to be like, well, this probably is not going to work out for us. But then we'll do mySum and items 3. So I'm going to go ahead and copy this. Let's go ahead and make sure items 3 is in our shell, and it is. And now we'll do sum of items 3, and it goes, we get this error. Right? We've seen this before, or at least if you've tested some things out, you may have seen this. Now this error is an example of some of the shortcomings of that sum function. However, our mySum function, if I hit enter, we have to define it, of course. So this is a good thing to see, is it's saying it's not defined. So that means I just have to copy this and paste it in. And now we can use mySum function, and we come in here, and it actually sums up everything. So it goes through that list, looks for integers and floats, and then it adds it to the sum. Now it's only on that top level of a list, right? So if there's a list within the list, it wouldn't do all of those other things. But the point here is it's actually coming through and summing everything up for us, right? Which is really cool. So now we can go one step further. So now that we have our mySum function, we could also do myAverage function, which would basically take, it would get the sum, it would get the length of that list, and then return it back. So this one's a little bit more complicated for a very specific reason, which we'll talk about in a second. So first off, we'll just do what we intuitively think it would be. So I'll do myAverage, and then I'll say my num list is what it's going to take in as an argument. And then we want to get the sum. So we'll say the sum. So my sum equals to my sum function with my num list in here. Okay, so I'm actually going to stop here for a second and change this from mySum to the sum. And the reason for that is I don't want it to be confused with the name of the function with the variable. So the sum that I'm getting is from our list. There it is. And then the average intuitively would be, we want to say the average number, so the total number of items. So number of items in the list would be the length of my num list. And now what we're going to do is actually return the sum, so the total, divided by the number of items times 1.0, right? Because remember that float thing. And then we're going to go ahead and return that. So I'm going to just go myAverage, and we'll do items 3. Okay, So let's go ahead and take a look at this. I'm going to copy that, paste it in there, and we see 447. Okay, so that's what the average is saying, but my sum says something slightly different. And actually, let's count how many numbers there are. There's 1, 2, 3 numbers. So let's divide my sum, that original one. Let's divide that by 3.0. I hit enter, and I get a much bigger number, right? So this is where you have to think through your functions. What did we do wrong here? Well, the number of items is not actually based off of the list, but rather the number of items that come from my sum. So this is going to now we need a new function called count ints or count nums, and it will say my num list again. And I'm basically going to do the same thing as my sum total, but now instead of actually adding to the total, in this sense, I'll just say total plus equals to 1. And now it's going to give me the numbers, the amount of numbers that are actually in there. So the number of items is no longer the length of my number list. Instead, it's going to be count the numbers there. And we'll go ahead and actually I'm going to keep that as an item. So I'll comment that out and paste this in here. And we'll do count nums just like this. And we'll copy that one more time. Oops, we got a little bit of a spacing issue here. Try and copy and paste one more time. And count nums is not defined. Again, we have to define everything. Notice how Python gets mad at you if you don't define stuff. That's really important. So let's go ahead and copy this again. And there we go. We get the actual average, the correct average, not what we thought was the intuitive average. So that is how we define our own functions. There's a lot more things that we can do to this, but doing it in math makes it very obvious as to how functions can work. And when we intuit it out, or at least go through all the steps, we start to think of how we can do these things differently, right? So my sum is a very simple function that really just parses out numbers and puts it into a total, brings us back that total. And then the count nums function is another very simple function that basically counts the number of numbers inside of any particular list, and then it returns that number back. And then our average function basically just averages those things out. Now, you could obviously update these into being a little bit more advanced, and it's actually very simple, but the way it is right here works just fine. And how this is, I would challenge you though, how do you make this one function? That is the thing I'll leave you with, and I'll actually put it in the code at the day 5 start end underscore bonus.py, where this is day 5 functions start. I'll have an end file, which will be all this stuff, and then a last file, which will say underscore bonus. So if you have any questions on functions, let us know. We will definitely come back to functions. These things we will cover a lot, and we have to. So if this doesn't fully sink in to you yet, that's okay. The key things to remember here: functions, to define them, to create functions, you have to use def. Then you give a function name using underscores. Then you can either pass parameters or arguments in here or not. We'll talk about that too. Then what you can do is return something. So functions, you put something into it, you can return something out. It doesn't have to do that, but it can. And then finally, to call them, you use the name of the function with parentheses and any given arguments in there. Again, we'll be using functions a lot, so hopefully by the end of 30 days of Python, you'll definitely understand it. Anyways, thanks for watching, and we hope to see you tomorrow.